You ready? All right, guys, so what I'm gonna do is I'm gonna go over special functions today. These special functions is gonna be a combination of things that we've learned in Algebra 1, things we reviewed right here in Algebra 2, but it's gonna get us to where we need to go post Algebra 2. So this is college level stuff that we're having to learn right now, going over these special types of functions. The first function I'm gonna go over is piecewise functions. There's 2 steps, if I were you, that I would follow when I'm graphing my piecewise function. Basically, what a piecewise function is, you're only graphing that portion of the function that's within the area of a domain. So that's where we're combining the Algebra 1 with what we have reviewed in Algebra 2, like graphing lines, graphing quadratics, graphing parabolas. We're combining all of that together. So you're only graphing the portion based on what the restriction of the domain is stated. All right, so let's look at the first step. Step 1 to graphing your piecewise functions. I would go ahead and restrict my domain. So I would mark somewhere on my graph where my domain or where my graph should actually be considered. And then we're only going to graph our line or graph your parabola within the area of that boundary of your domain. So basically look at your boundary as a restriction. Your domain is restricting it only to a specific area, and that's why they call it a piecewise function. We're only going to graph the part of the piece of the function that's within the area of that domain. All right, so let's get started. All right, so it says a piecewise defined function is written as using 2 or more expressions. On this worksheet, we're going to get up to 3 expressions in some of these. So it's really going to be key and important that we're able to remember how to graph a line and how to read domain to where we're able to actually do that restriction. All right, so I'm going to go over the first example, and then we're going to do problem 1 together. All right, so it says graph f of x, we know f of x means the same thing as y, equals 2x. So I'm only going to graph that portion of my graph. Where are we going to graph f of x equals 2x? Where our domain for x is less than or equal to 2. So this is where I'm going to go and notate on my graph to where I'm not doing a lot of scratch all over the place, is I'm going to actually restrict my domain. That way when I'm graphing this line, I'm only grading within that window. So it says x is less than 2. So I'm going to come on my graph, and I'm going to find where is x. This is my x-axis. Where's x? 2. Well, x is 2 on my x-axis right here. So now I'm going to actually mark off at the top, and I'm going to use purple. And you guys can use colors if you want to. I'm going to actually show up here where we only want to graph the portion where it's less than 2. So that means it cannot equal 2. So I should have an open circle. That doesn't look open. I can do that. All right, so 2 is here. Open circle. And then my graph should only be graphed. My purple graph, my first graph, should only be graphed in this area of the boundary. So now when I come over here to f of x equals 2x, I can graph the line, but I'm only going to graph this line on this portion of the boundary. And I know I should include an open circle because it cannot equal 2. All right? So that's why they came here and they put an open circle on 2. And now they're graphing this line, 2x. So if we're graphing 2x, I'm going to start at my y-intercept, which is 0. mx plus b. We have our mx, but we don't have a b. That means our b value is 0. So I'm going to put a point on my y-intercept. And then I'm going to apply my slope, which is up 2 over 1. Up 2 over 1, but I see I'm on 2. So I need to put an open circle here. All right? So I can stop right there. That's my stopping point. That's within my boundary. Then I'm going to go back to my y-intercept, and I can also go down to left 1. Down to left 1. The reason why I'm going down and left, because I have a positive slope. Down is negative, left is negative, a negative over a negative becomes a positive. All right, and then I can go and connect this line here. All right, now I'm gonna switch colors again. That way you can track me. And I'm gonna go to pink. My next line is gonna be pink. All right, I'm gonna go to my domain first and I'm gonna show where my pink line should be graphed. So we're reading this domain. X has to be greater than or equal to 2. So once again, I'm looking at my x-axis because we're talking about a domain, x. Where is x2 at? It's 2 here along this line. But where is it greater than or equal to 2? It's 2. I can put a point that's solid up here for my pink line, and greater than 2 goes to the right. So whenever I graph this line, I'm only gonna graph within this pink boundary. I hope y'all are able to understand this. And we got another problem we're gonna go over. So now I'm gonna graph this line. My y-intercept is -1. mx plus b. Our y-intercept is -1. So I'm gonna come and graph -1. I can put a point here, but if I put a point there, it's outside of my area for where my pink line needs to be. But I'll just put a little dot. That way y'all can see where we're going with this. From -1, I apply a slope. My m, it looks like it's 1 because that's the number that's in front of the x. So if I go up 1 over 1, all right, I'm still outside of the pink area. Up 1 over 1, now I'm in the pink area. I'm within this pink, where my pink line is at. Up 1 over 1, up 1 over 1, up 1 over 1. And we see that's where they graph that line at. And I'll graph it in pink. Solid circle here because it can equal 2. And then we're only gonna include this portion of the graph. So if we're looking at this purple line and this pink line, this is gonna be my 2 piecewise functions. I graphed it by marking off my domains up here. And this is just a key and a guide for me to remember where I should be graphing at. And it also keeps your paper a lot neater for you to follow. Any questions? Let me know, send me an email through Classroom and I'll answer it for you. Also, you can pull up some extra videos besides my video. That way you're understanding piecewise functions a little bit more. All right, so let's go on to example 2, or this next problem. Number 1. All right, it wants me to graph my function and identify the domain and range. All right, so I know over here, my domain on the first one, and I'll do colors like I did before. All right, so my first line is going to be pink. Since I'm already on the pink color, my first line is gonna be pink. My next line is going to be, I like using the pretty colors. I'm gonna say my next line is gonna be purple. I'll underline this in purple. And then my next line is gonna be blue. I'll underline this one in blue. All right, so let me go back to pink. We're looking at the first line first. Take this a piece at a time. Our domain is we wanna only graph this line where x is less than 0. So I'm gonna come over here on my graph. I'm gonna find 0 on my x-axis. 0 is here. And then I only wanna graph the piece that's less than 0. So I know I should have an open circle at 0. And then I only want to graph the piece that's less than in pink. It's going to go that way. Okay? Now I can come over here and graph this line. X plus 2 is the actual line. So I'm going to plot my y-intercept first at 2. All right? 2 is way over here to the right. So 2 is going to be 1, 2, somewhere on this line. I don't have to worry about graphing over here in pink because that's not a part of my domain. All right? But for the sake of graphing our line, I'm going to go ahead and plot my 2. 2 is here. I'm going to put an open circle. My slope is up 1 over 1. So if I go up 1 and right 1, that's not going to be included in my domain. But I can also go down 1, left 1. 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 I can go ahead and connect that line and draw it. And that's not the best line, but we get the idea. So that's where my pink line is going to be graphed. All right?
Richardson, Destiny Perez, Karen Wallace, Marcus Edwards,
all right, I'm going to switch to purple.
Carmen McDowell, Leila Godoy,
all right?
Hazel, Tanala
Our purple graph. Look at this domain. Now, this graph domain should take you down a trip down to Algebra 1 because you got a lot of domains and ranges written in this format right here. It's called interval notation. So I want to graph the piece that's less than or equal to 2. All right, and it can equal 2. So 2, 1, 2 is here. So I'm going to put a solid circle on 2 above the 2. And then, but greater than or equal to 0. I'm going to put a solid circle above 0. The rest of my graph should be in between here. All right, we get the idea. It's only between this segment right here. All right, so now I come over here to the graph. It says 2x plus 5. Where is 5 at for my y-intercept? 1, 2, 3, 4, 5. Right here. All right? And then my slope is up 2 over 1. So if I go up 2 over 1, I can put a point here. I'm going to do that one more time. Up 2 over 1. I'll say it's about right here. I don't like these markers. All right? I know this is a solid circle. So I'm going to draw a solid line up here flying around in space. That's where our line is going to be. We got as close as we could to where this graph would be. It's going to be somewhere off the grid up here flying off. Last line. I'm going to switch to blue. All right, restrict your domain. So we're gonna show where our domain would be. X is greater than 2. I'm gonna come on my domain, I'm gonna find 2. 2 is right here along this vertical line. It has to be greater than 2. It's not equal to. So I'm gonna write blue, greater than. I'm gonna put an open circle on greater than. And then it has to go this way. That's where it's greater than 2. Going that way. So I know when I graph this last line, it can only be going this direction. So I'm going to plot my y-intercept first. My y-intercept is 1. I'll put a dot there so I know where I'm starting from. And then my slope is down 1 to the right 1. So if I go down 1, right 1, nah, can't graph it there. Down 1, right 1, can't graph it there. Is that within that range? Yeah, it is. It's within that domain. So if I can start it here with an open circle, then I'll do that again. Down 1, right 1, put a point. Down 1, right 1, point. Down 1, right 1, point. My other line is going to be going this direction. And it's a ray with an open circle because it's greater than 2. This is where it is 2. And I graph the portion that's greater than, that's why we have an open circle, then 2. Everything greater than 2 goes that way. Now when I look at the pink, blue, and purple line, I know that's where my graph is. And if you wanted to, if you had an eraser, you can go and erase these boundary lines. That way you know that this line and this line is not a part of my graph. It's only where we see actual lines as part of our graph. Okay, so what I want y'all to do is practice number 2 and number 3 in that same format. You're graphing 2 and 3. Step 1, graph your boundaries. Where do you get your boundaries from? By your domain. By your domains. You have 3 domains listed on problems 2 and 3. Then after you do that, then you can go and apply how do you graph a line within that area of your domain. All right, so graph your boundaries first. After you graph your boundaries, which is specified by your domain, then you can go and apply your slope. Apply your line. All right? Let me know if you need some help or working with this. We can take our time. Remember, we have tutoring on Thursday here in Algebra 2. So Anybody that wants extra work, especially on this is fresh on our brains, come on Thursday after school, 3:30 to 4:30, and I'll help you make sure you understand how to graph these piecewise functions. This will be TSI tested. This will be something that will continue on to college algebra and when you get to college. All right? Thank you guys for tuning in. Let me know if you need help on piecewise functions.